Good evening from India. I'm Karishma. I'm a youth delegate to the World Water Council. I also work as a financial journalist in India, covering the India's economy. Today's session will focus on theme 1 of the online youth congress, that is water-related disasters and climate crisis. We have interesting presentations and discussions surrounding topics on enhancing wastewater treatment. Specifically, we have certain key interesting projects on textile aspect, leakage of water flow in pipes, biomedical waste generation, and of course the pipe water aspect. I'm delighted to tell you that this session actually covers a diverse representation and discussion that covers key regions across the globe. Before we proceed with the session, I'd like to quickly introduce the mentors, the 3 chief mentors who will be taking the discussion forward. It's my pleasure to invite and welcome, we have Dr. Oyaya, who's UNESCO Water Specialized Center from Nigeria. We also have Ms. Capucine Dupont from UNESCO IHE, that's Delft Institute for Water Education, Netherlands. And we have Mr. Mustafa Samad from Bechtel Corporation, United States of America, followed by a series of speakers. My colleague will also be there with you in this session since I have to leave early, but I wish you good luck and we can open the session. We can start with Dr. Yaya to take this forward.
Thank you very much for the introduction. I am very pleased and I feel privileged to be a mentor in this webinar. I am the director of the Regional Center for Integrated River Basin Management under the Category 2 Center under the UNESCO, located at National Water Resources Institute in Kaduna, Nigeria. The topic getting to do water-related disasters, particularly looking at flood and drought, under the aegis of youth involvement. I believe that the global activities mainly now belong to the youth. Why? Because within the sector, it's quite obvious that while we can boast of a number of experienced professionals who are actually aging, but we have a vast science professionals who can be adapted to understanding water-related disasters at their very youth age. The earlier session, I was quite proud to see young professionals making presentations. And catching them young is actually a very, it's quite hard because we need to have a transfer of knowledge and transfer of technology to the younger ones who are a bit sharper and their own the realm they find themselves a bit much more advanced and much more sophisticated than what it is in our own time when we're young like them. So there's no doubt in this era of ICT and some other new inventions and innovations, science, technology and innovation taking its toll. So now, talking to the topic as a mentor, I will say that drought and flood and water-related disasters have come to stay. There's no way we can totally prevent them. What we need to do is to adapt all manner of possible innovation to manage them. Just like the COVID-19, it got to a point now where the world says, okay, we just have to just deal with it and let us remove all the structures that have been restricting movements, restricting contacts, so that we can live with it. So the same way with water-related disasters, we have to live with them. But what we need to do is how do we develop resilience to minimize it? Now, I want to say that we need to actually really monitor our climate very, very closely. If you look at the young professionals or the young generation, particularly that are that are given to monitoring weather, they need to be very proactive. Now, let me give an example. In my house, I just discovered that in Nigeria, we are experiencing a very dry season in this April. But when I wake up in the morning, my roof has a way of collecting water and passing it through a pipe beside me. And you see dot of water on the ground, which shows clearly that despite the fact that the weather is supposed to be dry, but the humidity, water in the air is still there. So we may need to strengthen our indigenous knowledge, which rests in the hands of youth maybe in rural areas, because information from them can equally help us to adapt to this climate change that leads to water-related disaster. Another thing again is, if some people, some people are very used to predicting where rain will fall, when it will fall, and from which direction it will come, by merely standing in their house or in their houses and looking at the direction. When they see cloud forming and they say it's going to rain, when they see another direction, when there's a cloud, where cloud has formed, they say, it's not going to rain. How will you know? How do you know if you ask them? And at times we go to the site, go to the rural areas to work, and we discover that such predictions, they come true. Your fear of having rainfall as a result of clouds forming in one direction, or by their prediction or by their analysis, you discover that it comes true. And these are people that didn't go to school. They have no formal education, but they have been able to develop a tool, indigenous tool, to monitor climate changes. So some of these areas, we need to look at it and see how we can, can use our youth in this living in this area to feed the central climate information system. Then we can juxtapose it with the regular professional data that we can collect through temperature monitoring, humidity monitoring, evaporation monitoring, and evapotranspiration measurement, and juxtapose them together for good decision-making tools, and that can help us to monitor and suggest and from time to time develop resilient tools to mitigate climate change. So the final one I want to say to that because of the aging the aging process within the professional group, there is the need for us to monitor our rivers much more closely, particularly we in Africa. If you check very well, discover that a number of very top-class hydrologists, they are facing away. They are, some of them are retired, and we don't have the right hand.
Δεν με πήραν τηλέφωνο, είναι ηλίθιοι οι άνθρωποι.
Nicholas, you're audible.
Συνήθως λέει, κύριε, το πρωί στέλνουμε μήνυμα ότι ξεκινάει ο τεχνικός ή οτιδήποτε άλλο. Είναι ανεπίτρεπτο αυτό που σας συνέβη.
Nicholas?
Sorry, is my time up?
Sorry, I think there's a technical...
Το καταγράψαμε εμείς, λέει, εμείς στεναχωριέστε.
Hello?
Τι να σου πω, ρε, στον Παύλο, στη φωτιά, δεν ξέρω. Έγινε που πεις. Κομμάτι κάνει.
Dr. Yaya, I'm so sorry. We'll just take a second. I'm trying to convey to Nicholas that he's audible.
That's okay. No problem.
Την Παρασκευή. Δεν είναι κανένα πρόβλημα. Μη στεναχωριέσαι. Μη στεναχωριέσαι. Έγινε πατέρα μου. Συνεννοήθηκες. Ωραία. Μη στεναχωριέσαι.
Nicholas tried conveying it to him on message.
Ξέρω. Το ξέρω. Καλά.
Okay, that was successful. I'm sorry, Dr. Yaya, we had to cut you in between because of that. If I could, are you still with us?
I'm with you.
Okay, that's great. Dr. Yaya, if you could just sum it up in the next 30 seconds so that we can have other speakers also, and then we'll start with the presentations.
Thank you very much. I just want to say that in closing, I just want to say that we should look at how we can support this youth. I support utilizing the availability of the skills and professional skills of youth to strengthen our resilience to climate change through effective management of our water resources using, like I said, how we can explore to the maximum the use of indigenous knowledge, traditional knowledge, to monitor our climate and see to it that we transform such information into assisting the people in mitigating flood and mitigating drought. Thank you very much.
Thank you very much for your inspiring words. I'd now request Ms. Dupont to please give a short opening before we, of course, go to our last mentor.
Okay, thank you, Karishma, and yeah, thank you for inviting. Maybe just, I have a few slides. I hope we are still on time. I can show them, right? Because, yeah.
Yes, absolutely.
Yeah? Okay, so I will do that now, and please confirm me when you can see them, with this the different screens and so on. Share. Okay. Can you see it?
Yes.
In full presentation mode, everything?
We can see your slide 1 definitely, and it shows us that the slide next to it is beside it.
Okay, so it's the wrong one. Check them. Okay, normally it was working, of course, not now. I don't know why it's doing that. Let me check. I don't know. Okay, let me start again. So it seems we have quite technical issues in this session.
Now
Okay.
it is looking okay, I think.
Yeah, now I think it's good to go.
You see the first slide only. Okay, so yes, so thanks again, and yeah, good morning, good afternoon, good evening, everyone. As was said, I'm a senior lecturer at IHE Delft in Bioresource Technology at IHE Delft Institute for Water Education, and let's start immediately in the next, let's say, a few minutes. I'm going to talk with you about. Let's see, now everything is not working. Yeah, now it's the slides that are not working. Okay, so in this session about water-related disaster and climate crisis, I found, okay, Well, I want to start just by reminding the title of the session that is about hazards like floods and droughts that require integrated water management, climate change adaptation, and disaster risk reduction. And my idea here is to show how this can be connected with my topic of research that is about how to turn bio-waste into a resource, and more specifically via using biochar as a value chain. So maybe you are not familiar with that, and maybe you are not familiar why it can be connected to the topic. So I'm going to present you that, and just in one slide explain you briefly about the topic. The idea is that you can have different types of waste that we can call resource because they will be valorized. And those waste, they include dry resource like wood residues, agricultural waste like rice husk, and they contain less than 60% of moisture, of humidity. On the other hand, you have the so-called wet resources that contain more than 60% of moisture, that can be very wet, a lot of water, and they include fecal sludge, sewage sludge, or agri-food waste, for instance. The dry waste, they can be converted by a process that is called pyrolysis. Pyrolysis, it's typically, you will increase the temperature of the waste between 300 and 700 degrees Celsius in the absence of oxygen, atmospheric pressure, and under these conditions, it will give rise to some volatile matter, gas, CO, CO2, CH4, some condensate, water and tars, and that are organic compounds. And the main product that we want is a biochar that is a dark material, as you can see here, carbon rich and porous. When you have wet resources like sludge, you can also make pyrolysis. The problem is you have so much water that what you will do, increasing the temperature, is spending a lot of energy in evaporating water. For that reason, an alternative is what we call hydrothermal carbonization. The name speaks for itself. We will use temperature, but also hydro, so the water. And it's also called HTC as an acronym. I usually take, to explain briefly, the image of the pressure cooker that we have at home, in which you will have your reactor. You put some resource in it, some sludge, for instance, you put it in it, you close, you increase the temperature between 180 to 180 degrees Celsius. You can have added some water if needed, and there will be an autogenous pressure. And again, the production of volatile matter, biochar, and also a liquid fraction that contains quite some organics and inorganics. In both cases, this biochar can be eventually upgraded. We can make, maybe you heard about that, making pellets, briquettes to densify it. You can improve its structure, and then you can use it. Don't be biased. I have put 5 arrows, but actually there are many, many applications. I like to cite an article that is entitled The 55 Applications of Biochar. Here I'm just listing the most mature or promising ones. And one is especially important in countries that rely on still on wood or wood charcoal for cooking. Especially in Africa, we have this, and it's the use of this agricultural residue-based biochar, for instance, as solid fuel to substitute wood for cooking and therefore avoid deforestation. Another application is the use of this biochar as a soil improving material to increase crop yield, also to improve water retention, and also to sequestrate carbon, so as a way to fight climate change. Application a bit more prospective, even if already partly applied, the use of this biochar as water pollutant for water pollutant removal, as an adsorbent, notably for inorganic pollutants like arsenic, and also gas treatments. Another option, more prospective again, is about the use of this biochar in anaerobic digestion as a catalyst to increase the biogas production kinetics. And lastly, I think all of you here have a cell phone. We are connected with a computer, so we use a lot of batteries, lithium-ion batteries, and in this you need carbon. So it's a carbon-based material, and we can try also to use this biochar. One thing, what are the technical challenges that need to be solved by researchers before implementation of this value chain? 3 points just to say that we need to design, and it's always the same with chemical engineering processes, you need to design efficient, robust, and cheap technologies. Also, you want to recover the byproducts. You have a solid, the biochar, that is very nice, we want it, but what about the liquid and the gas? And lastly, the question is about understanding the link between resource, process, and product, because here I have talked about biochar, but I should talk about biochars. You have very different resources. If you use wood, if you use rice husk, or if you use fecal sludge, the properties will be very different, the physical-chemical properties. Also, the process condition can be different, and therefore the product properties and the performances in the application. And it is key to understand and model the mechanisms that connect resource, process, and products. This is all the type of challenges that we are trying to solve or to contribute to solve at IHE via lab experiments and modeling, that with our focus developing country context. I'm just finishing with 2 slides just showing a few ongoing studies, and especially ongoing study by young professionals, because this, I was involved, but this is mostly their work. It's in the frame of a project called NAIMA, a European project in which, so Abdullah Katarne did his MSc thesis, and Julie Michel is doing her PhD thesis. And we were talking about floods, the risk, etc. In this project, we have investigated more particularly river driftwood. As you may know, it's a risk for hydraulic infrastructures because it increases, and it's not recent, you see the black and white picture, it increases the destructive power of floods. Also, it accumulates in dam reservoirs. At the same time, this driftwood can also be seen as a poorly investigated resource. It has a significant potential worldwide along the rivers. It is already collected in dams for safety, and it has properties similar to forest wood that is a clean material. So we decided in this project to investigate, to have a picture of a dam between Lyon and Geneva and Genesia. We collected some driftwood. We converted it at IHE via HTC into biochar, and with partners, we tested it in battery, sodium-ion battery, the successor of lithium-ion battery. It's not a congress on electrochemistry, so I'm not entering the details here, but just to say that it looks quite promising because all the species of driftwood behave similarly and similar to commercial fossil-based materials. So they could be a green substitute. To end, the second example, a project that has just started together with African partner, Europe-Africa project called Bio for Africa. And again, a project, a study that is mainly led by a young professional that is Omar Abdeldayem, carrying his PhD thesis. And he has just started especially to work on invasive species from wetlands, from Senegalese wetlands, notably. And you can see some taifa, some water hyacinths that, again, we try to convert via HTC to biochar and test them as adsorbent for water treatment, because we know, of course, it's a major issue, and notably in rural areas. We are also doing quite some modeling to optimize the process, and I hope at the next edition, maybe Omar can give you a bit more about his results. More generally, to conclude, I was quite specific on my topic, but if I have a key message for the people, the young participants here, is really what I learned so far is the importance of collaboration between researchers from different fields. The studies I have shown, they would not have happened if I had stayed actually in my former place, in which people were more all about biomass, about working on waste, etc. They could happen only because I joined an institute dealing with water. It means working together with people having a totally different expertise, different viewpoints, and this is the way how original ideas, to my mind, come to solve complex problems. This said, I would like just to thank you for your attention, and I think we have some question in the Q&A part, if any. Thanks. And Karishma, I leave you the floor. If you are there. Karishma? No? Shall I give you the floor, Mustafa?
Yeah, seems like
Oh?
she may have left
Okay,
the
so
room. She said initially she would be leaving.
We will continue. Okay, I give
Yes.
you the floor.
Yeah, okay. I would have maybe a very short presentation, and then maybe we can go into presentation by the young professionals. My name is Mustafa Samad. I work for Bechtel Corporation as a principal hydraulic engineer. My company works in large construction type projects. I plan to kind of present some questions about, yeah, let me share my screen first. And no, not this one. Give me a sec, I'm just trying to still. Just tell me when you see my screen.
Really, we were seeing it before.
Oh, you were? Okay, I'm sorry.
Yeah, the first time we were seeing it, yeah.
Okay, then I'll do it again. Now, do you see my presentation now?
Yes.
Okay. Yeah, that's great. Yeah. So, so I'll be talking about some of the work that we have been doing in the company, and then kind of pose a question for our young professionals that how the water-related issues that we deal in very large projects, when combined with climate change, can affect and can modify the decisions we take in the design space. My company, as I said, it works in mostly 4 different business sectors: the energy, infrastructure, mining, and nuclear security and environment. In the energy sectors, the recent large projects are mostly on the LNG side. So these are liquefied natural gas plants. Typically, you would be built on a nearly a greenfield site, very large site, typically located on a water body where it can be transported by tankers and so. So in most cases, you will see where the 2 pictures on the bottom right here are showing a kind of a new plant just being completed in Australia, where thousands of acres of land being developed, new water infrastructure built for transportation and so. And in the process also, it affects some of the environmentally sensitive areas, like the top photo there, which shows that a road needs to be built through an intertidal salt marsh area, which is environmentally very sensitive. So, this is one example of the large project affecting our environment, where water is one of the biggest concerns. The photo that I show now is another LNG project, where you can see the band of the green along the shoreline is mangrove, and then this environmentally sensitive mangrove area, we cannot disturb it, and we needed to maintain the mangrove growth for biodiversity. And so these are challenges that we need to account for when we're constructing large project in the energy sector. The infrastructure, I have some examples here from, say, motorway project, and this is a Kosovo motorway project which parallels a river, and it crosses the river at many different places along the valley. And so the river health with this big construction becomes a priority, and how do we decide on what kind of design parameter we use for maintaining the health of the river, and in the process also account for climate change. This is another view of the motorway where you can see the stream right by the motorway. Another example is a new airport, and this is in Doha, Qatar. This is a new airport built in there where a very large area were needed to be reclaimed from the Gulf. And then the last two examples are on the rail sectors that we work on. This is the high-speed rail in the UK that connects UK with the rest of the Europe, and then this is an expansion of their underground system for the Jubilee line. So all these big constructions have large interface with water bodies that we need to consider. Same with the mining field where we, so this is a photo of a milling process where you use a lot of water in the milling process. The water comes from the natural sources, sometimes very large desalination plants needs to be built to get the water, and then the water needs to be transported hundreds of kilometers and very high altitudes where the mines are located. So these are all challenges related with water, and we need to design them in a way that we have a sustainable environment. And at the same time, we are like resources are not really wasted. And the last sector here would be the commercial nuclear sector that I will be focusing on. I have several pictures of nuclear plants here. The first one is in the USA. This is a plant in the south of Miami, where a kind of an intricate open channel system was built for cooling purposes. So the water was taken from one side and discharged through an artificially constructed canals. This is hundreds of miles of canals altogether. And then the heat would be dissipated when it's flowing through that narrow canals. And so that the plant is located on an environmentally sensitive bay, it's Biscayne Bay, and so the bay is not affected. This is another one in the USA. This is on the Chesapeake Bay near Washington, D.C. This plant uses the water, kind of once through water coming in directly from the bay. And the one next is in the UK. This is in the planning stage, not being built. So the photo here is kind of a rendering of like artistic rendering, and the plant would be located in Wales. It's still being discussed, and it also would use a large amount of water. And then the last one I will show here is a plant is being built right now in the US. It's in Georgia, where it uses cooling towers to reduce the quantity of water coming in. So all the other plants I showed you, what they call uses once through cooling, where very large volume of water is needed for cooling of the nuclear plants. But once you go through a cooling tower where we recycle the water in the cooling tower for cooling purposes, the withdrawal of water becomes much less compared to once through cooling. So these are concepts then we need to apply in our design process. But even before that, before we go for designs, all these large construction would require some kind of permitting process, and which will dictate what kind of design methods and design process we use. So how do you decide like on all these aspects? So obviously the public health and safety consequences are one of the big issues. The functional importance of the facility or the assets, another consideration, how we decide on the design criteria. And obviously the environmental impacts are one of the biggest consideration of all. If we go into the nuclear projects, I wanted to focus on that because this is my kind of my current area of work. There are additional considerations for nuclear projects because of their inherently safety concern environment. And in addition to that, you need to think about nuclear non-proliferation, the standardization used across nations, and come to an agreement between international bodies. And then these international bodies often will dictate what kind of regulatory environment the nuclear industry needs to go through for commercial nuclear power. I have a few names here, and I'm sure you know the IAEA, the International Atomic Energy Agency, or like countries, national specific organizations like the NRC in the US with very long history of regulating the nuclear industry and nuclear sector in the US. The bottom line here is that when it comes down to like allowing a plant to be built, you need to have a site-specific assessment done. And in flooding considerations, then we need to know whether the site where the plant would be built is safe from flooding or water-related hazards. And when you call it the water-related hazards, then we need to identify those external hazards that can potentially impact the site. And if it is tied with climate change, then obviously that consideration needs to come in. Now, how do we do that? The international organizations are actually taking two different approaches. In the US, it is more geared towards deterministic approach to define the parameter, the hydrological or hydraulic parameters. The IAEA takes more of a probabilistic approach. So because of the inherent safety risk of these type of structures, your return period or the annual accidents probabilities would be very low. IAEA accepts an AEP of about 10 to the power minus 4. So that's 10,000 year return period events. How do you assess such a long return period events when you have only data for maybe 100 years or maybe less than 100 years? So that's a big assessment challenge and risk, because the uncertainties are really too great to make any reliable prediction. The deterministic approach takes a different take altogether. They would look at the process and then define a kind of bounding scenario for that process, which physically cannot be exceeded, which means that you are then designing against a very extremely large extreme event, which makes your project inherently more expensive because you have to protect it for very, very large scenarios, which may or may not happen. One example I can cite here for the flooding aspect, the NRC's deterministic approach for storm surge, for example, ended up to be close to about 10 to the power minus 7 AEP. So it's about 1 in 10 million year event. Compared to what IAEA accept as 1 in 10,000 year event for return period assessments. But again, even in the deterministic space, there are challenges with changing environment and changing climate. So these are questions continuously being asked. And so this is the same thing I wanted to pose to our young professionals, that how do we take the water-related risk in a way where we can minimize the risk, we can make our designs more efficient, and then take forward the opportunities of power generation with such immense power in the nuclear industry. There are two other aspects I would mention here quickly. One is how do we define risk, and how do we define our approach to design. So one could be prescriptive, like the way in the US, the regulators provide a prescriptive methods of approaching it. One could be let the applicant or the industry decide how they want to solve the challenge of defining the water-related parameters. And that's the goal-setting approach that I'm showing it at the first here. The goal setting means that the applicant, you define how you want to evaluate the risk of a plant. So you have to define the risk, you have to analyze it, you have to present it, and then the regulators will either accept it or challenge it and reject it. So that's like the two different philosophies of design. and the tied with those are a concept of LRA or LRP, which says as low as reasonably achievable for some solution, or as low as reasonably possible. So this, again, the two different, slightly different taxonomy here, which has a tremendous consequence of like how we approach the solutions. So these are, again, questions which are still being like asked and trying to refine how we define the process in the industry. And then finally, on the climate change impact side, again, there are two approaches. One would be very definitive prescription that go ahead and add this much for sea level rise for this kind of project. One example is the UK, which the regulator says that, yeah, follow the UK climate projection for your project and use this particular value. While in the US, it says that you're using data which would be the basis for your design, but your data has a very limited accuracy, a short period of time in the historical space. So what is the uncertainty of the data? You take account for that uncertainty. And obviously, when you look at the data uncertainty and you're trying to project for the future, the potential change from climate change in the future comes into your mind. And that's where the regulators challenge that how you're addressing the climate change scenarios. And lastly, my last slide here would be to just kind of lay out some of the physical processes related to water hazard. Natural and external water-related hazards in nuclear plants. Is this sufficient? This is what like industry typically follows, that there are flooding from like local intense precipitation, like pluvial flooding, or extreme flooding on streams and rivers, pluvial. Is there a potential failure of like water impoundments or dams that can affect your plant? Storm surges, sieges, combined with wave actions, tsunamis. Is your plant in the cold region where ice dam can form and block the water, and the break of the ice dam can affect your plant or not? Is there a potential for channel avulsions, the changing the channel courses suddenly that may cause flooding or no water scenarios, or any combination of the events? And this is, again, like at times other aspects of like flooding complication may come in. For example, just the presentation made by Capuchin here is the debris that can block during flooding your water bodies. And that the same kind of debris can affect your cooling system in a plant and can affect the performance of the plant. So, so all these aspects are need to be like kind of looked at and then decide compounding with your climate change scenarios. So with that, I'll stop my presentation and ask the question for our young professional that how do you see like kind of fitting into nuclear industry, try to solve these kind of problems. Okay, thank you.
Thanks. I don't know if we should continue just as mentors or if the organizing committee is speaking. Otherwise, we can take it ourselves. It seems okay. Yeah. Okay. So yeah, I think we can thank you, Mustafa, and we can start with the first young professional in the list. That is, my spelling will be okay. Sandeka Waha, about COD fraction as means of enhancing wastewater treatment.
Yes,
okay.
Thank you.
Thank you. Sorry for the spelling. I tried my best.
No, it's fine. You tried. It was a good, I'd say it's Tandeka Jwaha.
Tandeka, okay.
Tandeka.
Yes, I'm just going to share my screen. Just give me,
yep,
can you fully see it? Presentation mode on. Can you fully see it?
Perfect. Feel free
Okay.
to start.
Yes. Okay. Greetings to you all. My name is Thandeka Jwagga. I am a young professional from South Africa. And today I will be presenting to you a part of my master's study, which is just a component of 2 or 3 other aspects of it. And I am looking at COD fractions as means of enhancing wastewater treatment. And this is a South African-based case study. In my presentation, I will be taking you through the background briefly of wastewater treatment, results and discussion, and all the way through the conclusions that were drawn during the study. If we look at wastewater treatment, historically, wastewater treatment was focused on the removal of COD. However, with development and time, there's been an increase in population, which led to more pollutants entering into our wastewater streams. So we're seeing more advanced processes being designed and more complex operations being instilled. And then we see that our authorities, and in South Africa, we have the Department of Water and Sanitation, which imposes discharge standards into our wastewater works. And currently, there's been more an introduction of mathematical models to try and improve process design and process optimization in the wastewater space. And what I'm looking at today is using these COD fractions as means of enhancing the wastewater treatment and trying to derive them in order for them to be a basis for a design or optimization model input. As I've highlighted, this is a South African-based case study of one of our wastewater treatment plants, which receives mixed effluents of domestic and industrial components, largely dairy and oil, and it's a conventional wastewater treatment plant. So the study is something that came from the fact that there's been an increasing need to optimize and predict the performance of wastewater treatment plants due to the complexities of treatment and stringent discharge standards. And then the objective is to use these COD fractions as means of enhancing wastewater treatment by deriving these fractions. When I say COD, it's normally something we refer to as chemical oxygen demand. And for those who are not in the wastewater space, it's merely our organic matter. And this serves as substrate for our bacteria in the wastewater treatment process. And for us to be able to remove and treat this, we need to infuse oxygen into the process and treat this organic matter that comes into our wastewater treatment plants. And failure to which this is a depiction of what you would generally see. This is one of the contributing factors to eutrophication. And one of the reasons we treat our wastewater is because if we discharge in excess, it would lead to oxygen depletion, and eventually we have loss of aquatic life and dead streams. These are some of the sources of your COD in our wastewater. And in normal practice, COD is analyzed as a parameter in its totality. However, with all these studies that we've conducted, we see that COD is much more than that. It is made up of components. And when we look at these components, we see that there's biodegradable versus your inert. And when we say biodegradable, this is what our actual wastewater treatment plants can treat. But unfortunately, the inert part of it is what leaves the process unaltered and goes out with our final effluents. So as you see in this depiction, I say more of the readily biodegradable component, because this is what we actually essentially want for the treatment process. And a part of that biodegradable, we're looking at having the readily biodegradable, which is easily broken down by microorganisms. And this is what we are actually looking for. And part of the study, we use a respirometer to actually find out the amount of oxygen that is within our system or within the sample that is input during the experimental process. So the process is looking at the amount of dissolved oxygen from start to finish, and then using a series of calculations to determine how much of the COD is within the system. And part of the results, as you can see here, if it was a normal process, we would just detect that we have a certain concentration. So this would be 100% of your COD. However, what we see is that part of that, we see that there's 70.5% of it is biodegradable, which is quite good, because literature expects that you have at least 75% of it being biodegradable. So it's not really a train smash, looking at the fact that we are in a plant that receives industrial effluent as well. Okay, so this is just a comparison in terms of your medium concentrated municipal wastewater effluent compared to the treatment plant. So when we look at this, we see that the domestic wastewater that we receive is similarly or similar to domestic effluent, as there's a 76 to a 71% concentration in that. And then from that, we can just essentially conclude and see that on average, the primary effluent is biodegradable COD was significantly higher than the inert, which is actually a good sign for our wastewater treatment processes. As I had highlighted, this is actually a source of food and also something that we need during other treatment processes. And then the wastewater treatment plant, primary effluent has sufficient substrate for COD removal processes. That is also alluding to the first point. And COD fractions resemble that of a domestic waste effluent. So which is, if you are in wastewater, you understand that industrial effluent produces another complexity and challenge in treatment. And then finally, COD fractions that are derived from the study can now be used as input into a theoretical baseline model for optimization of this wastewater treatment plant. I thank you.
Thank you, Thandeka, for the nice presentation. I think if there are questions, there will be anyway at the end. So feel free also to continue filling in the Q&A, and maybe we can move on to the next speaker. That is again my spelling, Oluwarinu Adepoju, about antibiotic resistance and biofilm formation potential of Plesiomonas shigellata from selected surface water in southwestern Nigeria. The floor is yours, and I see already your presentation.
Okay.
Not yet in presentation mode.
Can you see it now?
Maybe, yeah, if you put on the
yeah, we can see your screen, but it is, yeah, now it is on the presentation mode. Good.
Okay, thank you. Good day, everyone. My name is Adepoju Oluwarinu. I'm from Nigeria. I'll be presenting a paper titled Antibiotic Resistance and Biofilm Formation Potentials of Plesiomonas shigellata from Selected Surface Waters in southwestern Nigeria. This is a portion of my thesis work, which I'll be presenting on this particular topic. Plesiomonas shigellata gram-negative motile bacillar bacteria, facultative anaerobes, and they are mostly associated with waterborne infections. They are one of the emerging waterborne infections here in parts of the world, where and they are mostly associated with diarrhea-like infections. And there have been studies that have shown that these organisms have been showing emerging resistance to publicly available antibiotics in this part of the world. An example, most of it are the cephalosporin group, especially the third generation cephalosporin group. And according to additional report 2019, and biofilm formation is a very essential tool in antibiotic susceptibility testing of organisms. And this particular organism, there has been an inconclusive debate on the ability to form biofilm And based on different conflicting results from different researchers as regards the source and experimental condition and serological differences. So this study investigated the prevalence of Pseudomonas shigelloides in surface waters in Osun State, to be precise, in this country, and strain its antibiotic resistance and biofilm formation pattern. And in order to achieve this, we employed this particular methodology by isolating and identification using inositol brilliant bisort agar as media selective agar to identify this organism, and moving forward to molecular analysis, molecular identification using polymerase chain reaction, using a primer by Gonzalez et al. 2000 in Brazil. And we also further the analysis by doing our in vitro antibiotic susceptibility testing using Kibibawa-Dix diffusion method. And likewise, we did the detection of ESBL, extended spectrum beta-lactamase test, and using double-Dix diffusion, double-Dix synergistic test. And conclusively, we did the biofilm formation potential test and using test tube technique. And these are the results. From the results, we find high occurrence of Pseudomonas shigelloides in the wet season, because in this country, Nigeria, we have two major seasons. We have the dry and the wet season. And we have high occurrence of this organism during the wet season, which shows that the organism proliferates more, and we have higher isolation during this particular time of the year. And from the antibiotic susceptibility testing, it shows that this organism shows significant resistance to some of the publicly available antibiotics that we have, especially the cephalosporin, the CEPHEMs, like the cefotaxime, ceftazidime, and also level of resistance to tetracycline. And in contrast, shows susceptibility to the group of chloramphenicol, and some to the aminoglycoside group, which is also in line with a study by Adesina et al. 2019. And moving forward, we also did antibiotic resistance index for this isolate, because it's an important tool to understand the distribution of multi-drug resistant phenotypes of bacteria in a particular population. And after doing it, though the expected threshold, the accepted threshold of antibiotic resistance indices is 0.2, less than 0.2, or equal to 0.2, but we found out that isolates showed a higher index compared to that the acceptable one, signifying that this sample sites, these rivers, potential reservoirs of multi-drug resistant phenotypes of Pseudomonas shigelloides. And we also did the extended spectrum beta-lactamase producing test for the isolate, and we observed high occurrence of ESBL producing phenotypes in the wet season compared to the dry season. And conclusively, we also did the biofilm formation potential test, and following the same trend, we had a high occurrence of strong biofilm formats in the wet season. Likewise, though we also have in the dry season, but we can't compare it with that, the occurrence in the wet season, which shows and justify the resistance, exhibition of resistance by this organism to some of the publicly available antibiotics that are being used in this part of the world. And to wrap it up, the distribution and virulence and antibiotic resistance of Pseudomonas shigelloides vary according to sampling sites, and which indicate that source, geographical location, and anthropogenic activity appears to influence the pathogenicity and resistance of Pseudomonas. And I would say that emphasis is needed to be included that antibiotic resistant gene surveillance should be included in epidemiological studies and surveillance. Thank you very much.
Thank you very much also for the nice presentation. Yes, I think we are on time, and maybe we can just simply move to the next speaker, Kais Fedila. The title is about the effects of the combination of chlorella and lemna minor and textile industry wastewater treatments. Yeah. Are you there? I don't see Kais or another co-author, maybe.
Hello.
Hello.
Nicholas from the IT. Unfortunately, none of the authors are here, so we should continue.
Okay, thanks for telling. I think I saw the next speaker that is in the list, Jose Resilam Souza Mauta Ushoa.
Yeah, I'm here.
Yeah. Okay, perfect. So nice that you are already ready. It's about computer simulation of leakage water flow in pipes.
Exactly.
Yeah, so feel free to share.
I will share my screen. Yeah, just a minute.
Yes.
Can you see it?
Perfect. Free to start.
Great. So it's a pleasure to be here. Good morning. My name is Jessila. My supervisor and co-author is Professor Lima Neto. Our work title is Computer Simulation of Leakage Water Flow in Pipes. And we are from Federal University of Ceará in Brazil. So according to the World Bank, we lost daily in developing countries are around 45 million cubic meters of water. And the last report by the Smart Water Network Forum estimate that most of the capitals of the world have an overall water greater than 25% exceeded the acceptable level recommended by the International Water Association. So we need more studies, experimental numerical studies about the subject. But until now, the models that we have are quite simple. I present here 3 models: the Torricelli's equations, water leakage equation, and one by Casa Ivanzio. So these models ignore the soil leakage interaction, and as well usually ignore the axial flow, the flow regime, the discharge coefficient variation, and so on. So in this work we assess the impact of geometric, hydraulic, and hydrodynamic factors on water leakage in pipes through 3D CFG simulation. So I presented here the key steps of a simulation. Our geometry was quite simple: one pipe with a circular orifice, and we worked with 25, 15, and 100 millimeters of steel pipe with 3 millimeters and 6 millimeters diameter of circular orifice. And our inputs are the velocities and basically the velocities and pressure of experimental studies in the literature. I present here our mesh, and about the mathematical models, I mean the turbulence models. We use the main rings models, the K epsilon and K omega models. In the end, we simulate more the 120 simulation conditions, and we can compute the discharge coefficient, CG, by the Torricelli's equation. So I present here one of our results, the comparison between the K epsilon model and the K omega SST model for the same conditions as a function of the pipe diameter. And we can see both models present a great results. And we can see as well the K omega SST model are closer to the perfect agreement line. And if we look to the turbulence edge dissipation in the simulation, we see the greater the diameter, the smaller the turbulence for the same conditions. And we can associate this with the ability of the orifice to change the directions of the streamlines. So we can look to the streamlines and see that for the 25 millimeters pipe, half of the streamlines are toward the orifice, and in the other hand, about 50% of the streamlines are toward the orifice for the 100 millimeters pipe. And we are doing simulations, so we can compute that. So I computed that, there's a resume here. So we can say that the smaller the diameter for the same conditions, the CG, the discharge coefficients are bigger, as well the amount of flow coming out of the orifice. And this is in agreement with the epsilon integrations, the turbulence edge dissipation integrations in the circumferential section in the control volume. So these results indicate that the variation of CG as a function of the diameter pipe and the orifice shape can be attributed to the effect of the pipe curvature on flow converges through the orifice. And to sum up, we can say that CFG modeling allowed a confident analysis of the phenomenon of leaks. The RAINS turbulence models performed great. And this work, this computational work is inserted together with our other experimental work as a basis to the study of the discharge coefficient, CG, as a function of geometric, hydraulic, and hydrodynamic factors. And I hope in the future we can reduce the amount of non-revenue water in your systems. Thank you for your attention.
Thank you again for also for the presentation, very clear. Maybe then let's continue as we have quite a dense program. So the next one is from Sakila Laksan about a study on post-environmental, economical, and socio-cultural effects to the Sri Lankan Western Coastal Belt due to Express Pearl disaster. The floor is yours.
Yeah. May I share my screen?
Yeah, please do so. We can see it. Perfect.
Okay. So we are going to present on study on post-environmental, economical, and socio-cultural effects to the Sri Lankan Western Coastal Belt due to Express Pearl disaster. So we're going to present introduction, objective, research method, environmental and biological damage, economical effects, socio-cultural effects, conclusion and suggestions, and finally references as our content. So Express Pearl disaster is the most worst and devastating environmental disaster which ever happened in Sri Lankan seawater in Sri Lankan history. And a vessel carrying plastic pellets, fossil fuels, environmental hazardous substances, including heavy metals, was exploded in 20th of May 2021. So it's nearly 145 kilometers of beach line along the western and southern coast of Sri Lanka was highly affected due to this incident. You can see the red, in this image, you can see the red curved line shows the highly affected area in this map. And government restricted fishing in the immediate area around 50 miles per meter around this location, and also tourism were also highly affected due to this beach pollution. It is highly affected on country's economy also, as tourism is most critical income factor for Sri Lanka. And also there are recorded a high number of marine animal death cases along the beach line, which I mentioned before, including endangered turtle species, dolphins, and other marine fauna. And also minor level oil spills were recorded. Unfortunately, the government and other authorities were able to control high level oil spills, but minor level oil spills were recorded, and also beach and underwater pollution due to those plastic pellets. So main objective of the study is to identify how the disaster can gradually affect the environment, economy, and socio-culture of the community with respect to the time. In our research methodology, we have selected some most highly affected locations along those affected area. We have visited Sarakua, Vellavatta, Hikkadu, and Nigamo Lagoon and beach area for collection of our primary data, and also we have interviewed 7 number of people from the community to gather details of their economic and social issues due to this disaster. And also we have referred available literatures, news articles, and experts' comments for our secondary data. And we have identified post-destruction of the marine aquatic environment through them. Environmental and biological damage. So the main visible environmental disaster and was due to those plastic pellets. You can see this image, the entire beach and the shoreline was covered with these plastic pellets. And also there have a huge number of small and large scale fish and turtle death cases recorded. Actually, it's more than 100 turtle dead bodies were recorded at the end of the 2021 year after 7 months of the incident. And there was a seabed destruction. There was a possible seabed destruction due to the ship was sinking, and it was finally settled at the seabed. So the immediate sea area can be affected due to this incident. And there's a huge possibility to absorb hazardous chemicals and heavy metals to human food chain systems because people's consuming these aquatic based food resources. So there's a higher possibility to absorb these heavy metals to human food chain systems. And also those pellets are lighter substances, so they can float easily with water and affect more not only Sri Lankan region, but also neighbor countries like India, Pakistan, Bangladesh, and also Maldives likewise. So now I'm invite Mr. Thananda to continue the presentation.
Thank you very much, Sakila, and good afternoon, you all. So I'm going to discuss about the economical effects of this particular disaster. So the direct impact to the livelihood of the community of the affected area, as the majority of them are fishermen. They try to capture the fish resources in the ocean, the coastal belt around the Sri Lanka, and they depends on the ocean. So due to this particular disaster, it clearly affect for them. Sri Lankan government banned the fishing activities around this coastal belt. So because of that, they have lost their livelihood. Then high possibility to enter the chemical substances and hazardous waste to human bodies through the marine and aquatic based food resources. And therefore the lack of demand for the Sri Lankan popular seafoods such as cuttlefish, shrimps, and other types of fish dishes, which are very much delicacy and as well as very much famous. And Sri Lanka earned quite a lot of income from these type of exports. And due to this particular incident, such type of exports are basically missed to Sri Lanka. And decrease in the tourism attraction, which is started to boom suddenly after the COVID-19 pandemic situation, caused another economical damage to the country's economy, because the Negombo Lagoon and Negombo area is one of the most favorable destination for the tourist attraction. But due to this particular incident, total the aquatic environment and the coastal environment was destroyed and banned for the tourist as well. Could you go for the next slide, please? Yes, then the social cultural effects. So gathering of the public community to collect the substances and the material disposed from this particular vessel may cause quite a lot of social and cultural effects. People from the community can be harmed due to the unrevealed hazardous substances which release from the explosion of this vessel. And the disease can be spread easily among the immediate community along with the substances exposed to the atmosphere and the coastal environment. And finally, the conclusions and suggestions. So remove all the oil spills, plastic pellets as much as possible by using oil booms and skimmers. So we have to have a good preparedness for this type of incidents. In Sri Lanka is an island always covered with a very nice coastal belt. So we are always vulnerable for this type of disasters. So we have to have a well preparedness plan in this type of situations and disasters. And fasten the damage evaluation process and claim fund for the restoration processes. We have to have quite a lot knowledge about the international laws and rules and regulations regarding this type of incident, and implementing the rules and regulations for vessels carrying environmentally hazardous and toxics to avoid the further destruction. and the media have a responsibility to show the risk of gathering and collecting the substances and avoid as their national responsibility. And other than that, there's a one best positive impact due to the remaining of the burnt wreck or the vessel. That may be a very good environment for the biotic and aquatic species in the Sri Lankan coastal belt. There will be quite a lot of breeding grounds which will be creating within next few years in this particular burnt ship, the express whale. That would be the one best positive impact from this particular incident that we have identified with the interviews of the professionals. And this would be a very good lesson for the Sri Lanka to prepare for the future disasters and how to minimize, how to control, and how to manage this type of disasters, because that may be there in future as well, since the location of Sri Lanka is almost vital for the marine navigation through the world. So that would be a very good lesson that we need to learn as Sri Lankan people from this particular disaster. And next. These are the references that we use for our research work. And thank you for your attention. Thank you very much.
Thank you very much for this presentation as a duo. So it's really nice. Maybe we can move on. I think I saw in the attendees Mustafa Safarov that is going to talk about the debris flow monitoring and assessment using UAV from Tajikistan.
Can you see my screen?
Yes, perfect.
So thank you for giving this opportunity to make presentation here today. So my topic is a topic about debris flow monitoring and assessment using UAV in southwest Tajikistan. So Tajikistan is a mountain country where 93% of the territory is mountain, and it's located in the center of Eurasian continent. So with elevation from 300 meters to more than 7,000 meters. So as you can see, it's a very mountain country. So UAV is also very relevant in the mountain terrain in Tajikistan, and can be used in various fields, including hydrology and disasters and study of water resource and others. So you can see the process of and the step of using of UAV in different research in this screen. As a result, in 2021, 9 districts of Tajikistan located in different heights were surveyed with UAV for monitoring environment, water resource, and disasters risk assessment. So you can see in this map in different high altitudes and where we use UAVs for investigate and do research. So in this map, you can see a debris flow map in Tajikistan, and the red arrows show the zones where studies of debris flow hazards with UAV, and also another territories, high mountains lake, which is a period after earthquake in Tajikistan. It's very dangerous because it's high mountains and maybe one day it can be destroyed. So I hope it's not. So another territory is also investigated where we make research of water resource and other objects. So in this yellow triangle, red triangle shows a zone of debris flow in Khorasan area, which we will discuss about. So this is the territory of the resource. This is Tajikistan, and this is Khorasan district. And number 1 is showing the territory which we make research with using UAVs. So as you see, the most precipitation falls in April and May, which means worth noting the most of debris flow in this area also recorded in these months, I mean April and May. So another slide shows the study area before debris flow, and you can see the irrigation canal in the top and the area of debris flow formation, and it is from capital Dushanbe highway to capital of the region, Khatlon Ridge is Bokhtar highway, and this is another one is that areas which is will be debris flow. So also you can see the territory is white. White is showing the territory which made aerial photography. So this slide shows the result of processing UAV images obtained in the process of aerial photography of the debris flow zone in the Khorasan district. So you can see the irrigation canal and debris flow formation zone here. So this is started, and in this picture you can see well. So another, this is debris flow deposits, and you can see a lot of houses, destroyed houses, and different roads between houses also destroyed. So in this picture you also can see the aerial photography of this territory, and you can see the school is also under the debris flow, and many houses here also showing, and this is a zone of debris flow formation. This is which I told about irrigation canal. Maybe it's also related with this. So in this slide it shows the dam of Khorasan district made by SRTM data, and also another is a digital terrain model which is made by UAV. As you can see the changing of territory. So the future, if something we can detect the change in this territory if you want to do research. This data also can be used for river basin delineation. So actually the result of research was the zone of formation and deposit as debris flow was and destroyed houses, and another objects was identified, and the deposit area was about 0.5 kilometers square. So the result of obtained with the use of UAVs make it possible to solve many problems related with monitoring and forecasting water objects and hazardous hydrological phenomena in changing climate condition, and also in hard to reach areas without risk with the people, and carry out mapping, make models, and prevent possible natural disasters related with water. So according to the result of the study of water resource of Tajikistan and hydrological hazardous process research related with UAV, some publications have been publicated. So it's a kind of scientific articles, monograph, and atlas you can see in this screen. So this is all, and thank you for your attention. If you have any questions, thank you.
Thank you very much. I think, yeah, if there are questions, we will ask them just afterwards in the session. So please all stay. And just maybe the last, let's move on to the last presenter, Ravikant Bhardwaj, about the analysis of COVID-19 biomedical waste generation in India and its impact on water resources.
Thank you.
Thank you. Yeah.
Greetings. Hello.
Feel free to start. Yeah, we can see your screen.
Greetings to all. I am Ravikant Bhardwaj, undergraduate student from India. And today I am going to present on analysis of COVID-19 biomedical waste generation in India and its impact on water resources. At the beginning of 2020, world has seen devastating pandemic in the form of COVID-19, which was caused by SARS-CoV-2 virus. Almost all developed and developing countries suffered due to this pandemic. India first felt the outbreak in March 2020, and till date, Lakhs of humans have died due to this pandemic in India. The principal mode of spread of this COVID-19 virus is through the exposure to the respiratory fluids carrying infectious virus. When an infected person comes to a close contact to a person, he can transmit the disease to one another. Thus, doctors have advised to use surgical masks, face shield, gloves, shoe covers, and personal protective equipment. These medical care accessories need to be replaced every day. Thus, accessories have been disposed as a part of household waste. On many occasions, these have been discarded by roadside, behind hospitals, on beaches, parking lots, and in landfills. Infected persons have also used overdoses of some medicines which were suggested by doctors to cure COVID-19. In India, it has been observed that few COVID-19 infected people after death have been dumped in river. As per BBC News, as per Central Pollution Control Board, India, the biomedical waste generation has increased due to this pandemic. In the present study, an analysis of biomedical waste generation in India due to COVID-19 during 2020 to 2021 has been done, and its possible impact on water resources have been discussed. Biomedical waste has been defined as per Biomedical Waste Rules 1998 of India, which states any waste which is generated during diagnosis, treatment, or immunization of human beings or animals, or in research activities pertaining thereto, or in the production of or testing of biologicals. So waste like discarded medicines, waste traps like syringes, hypodermic needles, plastic cast dressings will fall under this category. In the present study, an analysis of biomedical waste generation during COVID-19 has been done for India. Since it is densely populated, the spread of COVID-19 virus has also affected a large part of population. The data for individuals affected from COVID-19 has been obtained from World Health Organization, and data for biomedical waste has been taken from Central Pollution Control Board, India. Data from 2020 to 2022 has been used for study. The statistical parameters like mean, standard deviation, etc. have been used for the analysis of data. For data gathering, CPCB has developed a mobile application, namely COVID-19 BWM, to update the data of COVID-19 biomedical waste generation. As seen in figure 2A, till January 22, the 3 waves of COVID-19 have hit India. The number of infected person was maximum during April-May 2021, and biomedical waste also reached maximum in at this point of time. And these biomedical waste have been dumped in landfill sites or may be burned. In both the cases, it may have resulted in pollution of air or water. During this period, the mean waste generated per month was 3,283.66 tons, whereas the maximum was recorded in May 2021, 6,293 tons, and minimum was on December 2021, which was 713 tons. Standard deviation calculated for this period was 1,853 tons. The process through which different water bodies will be contaminated by medical waste has been expressed. The biomedical waste like PPE kits, syringes, plastic waste can be dumped in lakes, which will directly pollute water, or rivers. And if they are dumped in landfill sites, they can percolate and pollute groundwater. The possible water resource contamination which might have caused by biomedical waste is as follows. The leachate from dumping of biomedical waste at landfill site has capability to percolate the subsurface and cause groundwater pollution. Due to unawareness among citizens, the biomedical waste has also been dumped directly into rivers, ponds, or lakes. Thus, there are chances that pathogen contamination might be present in water bodies. The chemical components of pharmaceutical medicines may come into the water bodies through urination. Thus, concentration of these contaminations may have increased in water. Animals and human bodies have also been dumped in water bodies, which may have caused pathological contamination in water. Due to inadequate waste management during the lockdown in India, the waste loads in rivers and other water bodies might have increased. Plastic contamination in water bodies might have increased due to excessive use of plastic materials for biomedical accessories. The research on the effect of biomedical waste on COVID-19 in India on water bodies is still at nascent stage, and due to lack of proper data and equipment, it may take time to quantitatively prove the facts. And there are no such solutions proposed for the identified problems in this study right now. And these are the references. Thank you for attention, and I'm open for discussion.
Thank you very much for this presentation, which was the last one. So I think, yes, now it's time for the Q&A. Also, I will propose to the other mentors to give, I think maybe I can just read to start, because I see there is a Q&A question. I think was a question for one of the mentors, actually, if I'm not mistaken. It was during the first presentation. So I think it's for Dr. Yaya, I think. Are you there? Mustafa, I don't know if you see the other man. Okay, maybe my spelling also. Yeah,
yes, yes.
Sorry, yeah. I think it was for a question that was, is indigenous knowledge to be considered as wisdom or more raw information data?
Yeah. Sorry, what is the question?
Yeah, I think you can also see it in the Q&A. Is indeed indigenous. I think you were talking about indigenous knowledge, and is it to be considered as wisdom or just raw information data?
Okay, thank you. While indigenous knowledge is not a formal way of maybe expressing information, but experience has shown that it has aided formal information tools, you know, to make predictions and get answers, because the purpose is to see that as an integrated, an integrated way of gathering information and transforming that information into decision-making tools and transforming into action and impacting livelihood. So while I cannot suggest, I cannot support it being wisdom, because if it's wisdom, then it means it cannot be fully relied upon. But yet, it should be an informal information source that can aid decision making. So I think we should encourage it, indigenous or traditional knowledge. Now, if you may feel that in the developed world, it cannot be dependent upon, no doubt, but in the developing world, we need it, and we can use it to supplement the information that we get from the regular ways.
Okay, I think it answered the question, I think, quite exhaustively, so thanks. Yeah. Maybe, I don't know if you others, people in the panel have questions, or people as attendees. I don't see one.
If there's any member of the panel that wants to, any of the mentors that want to add his voice, but that is my pure view, and that's my answer, my definite answer to that question. Why? Because adaptable to the place, to the area where we find ourselves. Africa, as a developing continent, where indigenous knowledge and traditional knowledge, they are good tools, no doubt. And some people, a number of people have have such information, and when you are able to collate and utilize it properly, it can supplement our tool for good predictions and decision making.
Okay, thanks for this answer. Is someone else? I don't see any others in the Q&A, or at least, or answered. I don't know if people raise the hand. Otherwise, also if there are comments from the others, maybe, I don't know, Mustafa, if you have comments or...
Yeah, I have a question. Actually, I can ask a question.
Yeah.
Just to start the conversation. My question is for Jose. You presented on the computer simulation of leakage in water flow in pipes. So you had presented on a CFD simulation through which you showed that the coefficient of discharge actually is dependent on the pipe sizes and the curvature and so forth. So how do you plan to apply this in leak detection in pipe networks? And how, like, because you cannot possibly perform CFDs for all systems, right? So you have to come up with some simple methods to be able to apply it for leak detection purposes.
Thank you for your question, sir. That's a great question. Actually, one of our results as well is try to do a new equation for CG. And the next step is to put this new equation in, for example, on software like EPANet. So we can use this new equation, new information in the EPANet. But I agree with you, we can't use it in today's days, the CFD for the whole water system network, because we need a lot of computation and a lot of, maybe a supercomputer can do that, but in the engineering, in the field, it's not possible yet.
Okay, great, thank you.
Thank you.
Are there other questions? I don't see. Okay, I guess was all clear for everyone. Or maybe shall we wait a bit? And I think, yeah, otherwise we can simply say a few words of like to sum up.
Any question from the young professionals to the mentors?
Yes, I see. Yes. So you start, Mustafa. Thanks for breaking the ice now. Like, yeah. Thank you.
Actually, I don't have a question, but I just would like to say thank you for make this Congress for Young Scientists. And actually, it's my first presentation in English. So maybe I had some grammar mistakes. I had, of course, I have, but I think this Congress is a very good opportunity to scientists to communicate with each other, and also we can learn from you, young, from all the scientists, something new, and we can use this in our research in the future. Actually, why I choose my topic about UAV, because in Tajikistan it's not so many developed, because not so many research. So I was the first person who started research with UAV, and which is also connected with satellite data. And if anyone have questions and for collaboration, maybe for field work, and also can make me some letters and we can discuss about it much more. Because here we don't have any time to talk about everything, to show everything which we did in our research. So again, thank you, and welcome to Tajikistan. We are looking forward to see everyone in real life, and maybe in Europe, in Tajikistan, never mind. Thank you.
Thank you. I think you were a great ambassador, no, for the country, and it's also, it was a nice presentation, and first very good job. And okay, most of us are non-native speakers, so you know, grammar and everything, provided the communication is there, we could get to the point, and it's really the most important. Don't worry about that. I think based on my experience of French speaker that you may have understood. Really not a problem.
Thank you.
Yeah. And I see a question now that we have started a question from Tandeka, or a comment. You have raised your hand.
Yes, thank you. It's also just to express gratitude for this platform and opportunity. And further to that, to just ask the conference organizers if we will be getting participation certificates for the conference. Will there be any conference proceedings per se after the conference, as well as potentially just collaborations, if there's somewhere where we could see the abstracts and probably the email addresses of some of the young professionals, because I see there's an area of collaboration and opportunity and just learning more. You know, for me, it was quite a big platform. It's international, it's global. I'm from South Africa and I've learned quite a lot. So I'm still interested in reading up more of some of the research my fellow young professionals have presented today. Thank you.
Thank you. And I think thank you for the organizer is also with, I think, Elpida is in the room. That was, of course, the main organizer and involved. I don't know for exactly about the certificate, etc. I think maybe I see an organizing committee member that is there that might answer better than us as mentors about the question.
Thank you very much, all the participants, all the young people from the organized committee. Thank you very much, the mentor, for mentoring. This is time to finish this session. Thank you very much, all the young professionals, for the contribution to this conference. Thank you very much.
Thank you.
Yeah, thank you all. Yeah.
No,
especially the young professionals.
Yeah, and I see a question actually to the mentors, a very final one, maybe short to the mentors. What would be a recommended MSc program for integrated water resource management for young water professionals in Africa, recommended research areas or demand, especially in West Africa? Which is not maybe a quick answer, or I don't know if maybe also was, yeah. I don't know if there is, maybe I can answer about the MSc program that maybe you can come to make a bit of promotion, that you can come to IHE website, but it's completely advertising, so it's not the full answer at all, but maybe we can have a look and also maybe discuss during the coffee break, because I understood it's now the end of the session, right? No. Okay, I guess so.
Okay.
Yeah.
Yeah. Okay. Yeah. I think that's it. We can take it to the coffee break, and yeah.
Yeah. Let's see.
We can end this session. Yeah.
Yes. Okay. Okay. Thank you all for participating and giving these nice presentations to the audience. Thanks.
Thank you for mentoring.
Yeah. Thank you. Okay.
Thank you for organizing. Bye.
Bye bye. Yeah. Bye bye all. Yeah.
Please complete the questionnaire in chat. In the chat, there is a questionnaire. Please, young professional, to complete the questionnaire. In the chat, there is a questionnaire. Please complete.